All right. I hope all of you guys can hear me. Perfect. So today's session is going to be hopefully very interesting. I am Gopala. I'll be presenting this session along with Lavi. He's a super awesome colleague of mine, and we'll both be kind of helping you out. Anything you need in this session, you can reach out to me or Lavi. I work as an AI engineer, and Lavi is also a machine learning engineer at Google Cloud. So the name of the session is Building Real-Time Applications with Gemini Multimodal Live API. Now, a show of hands, how many of you have interacted with or seen demos of Gemini Multimodal Live? You know, the one where you can talk to it? A lot of people, all right. So the intent of this entire session is ideally supposed to be with laptops, but it's fine even if you don't have one. We will go through it and kind of will try to showcase the work, what we want to showcase, even if you don't have a laptop. So here's our names and here's the intro slide. This is not working, no worries. All right, so the agenda here is twofold today. We will show how do we use the Dev API to establish WebSockets, and then we will also see how do we build an enterprise applications using Vertex AI. So Vertex AI is Google Cloud's enterprise offering, wherein it's like a one-stop shop where you can build end-to-end AI and machine learning applications. Right, but before we move on to that, there's a quick thing that I want to do. I want all of you guys to open this URL and sign up for some credits. It's quite straightforward. Just the one thing that I would request you to do is that sign up with your personal email. Do not use your corporate IDs. Just use your personal email once again. It's for your own learning purposes. You have a couple of dollars worth of credits for this particular session. All right, I'll just take you through the next slides. So when you, first of all, all of you can kind of sign that, yeah. Okay, so we'll move to the next session, next slide. This is the screen that you should be greeted with. You need to sign in with Google, and then, of course, when you sign in with Google, use your personal email. Do not use corporate, all right? So once you do that, you should see a similar page where it says get access to your credits. You should see an amount of $5. And then once you do that, you need to kind of agree to the terms and conditions. This will help you get a GCP credit application. This is for all of the attendees here today. You can go back home and experiment with this. I mean, this you don't have to do it live right now, but it's good to sign up for this and then practice it at your home. Then you'll kind of create a Google Cloud project. Click to create a project and click on a new project. Fill in the name. And you need to select the trial billing account. If you're doing it with your phone, that's perfectly fine. You can use your phone to do this as well. I will show you step by step how to kind of do this. All right, let me just show you how to do this. So for example, if I go to this URL, yeah, so I've already kind of done it with my personal. I will click here to get credits. All right, accept and continue. Okay, it says credit successfully applied. Then we just wait for a couple of seconds. All right, we'll just skip past this. And once the credits are applied, you can see that your billing account is created. This is the Google Cloud platform, by the way. If you're not familiar, this is how the console looks like. Yeah, and once you're done with this, you can just go ahead and create a new project. It just says over here, how do you do that? Once you create a new project, you can go ahead and build something cool, build something awesome on that particular project, right? Let me just do that. I already have a project created. I can also create a new project, right? So no organization, and then I can just set up the project. So this is the way you do it. Again, this is just for an intro purposes. Please make sure that you redeem the credits within this session. The actual project creation stuff, you can do it back home as well. That's perfectly fine. All right, and if you have any questions regarding, if you need some help setting up or something like that, we have Lavi also. He may help you if you kind of want his help. So one more time, here's the QR. All right. So let's move to the main topics. And if you have any more doubts regarding the credits or the redemptions, we have a Google Cloud booth just outside the main, auditorium. Outside the main auditorium, you can go ahead and talk to folks there, and they'll help you out. All right, now let's move to the main content. So the first thing, like we discussed in the agenda, was the Gemini Live Dev API. Like I said, we'll talk about the Live Dev API as well as the Vertex AI implementation. Now, the Live Dev API lets you do rapid prototyping, lets you build solutions quickly before you consider moving them to production, right? Now, this is a live API, and that's a very important piece of information. What does it do differently is what we're going to look at. So when we talk about live applications, we use something known as WebSockets. Just a show of hands, how many of you are familiar with the concept of WebSockets? Okay, a lot of folks are familiar with the concept. So, so we have a REST versus WebSockets kind of a comparison over here. So REST operates on a request response basis, and each request requires a new HTTP payload and stuff like that. Whereas in Socket, you sort of open a connection, and then till the connection is active, it's going to keep it open, and that way two machines can interact and two servers can interact with each other. And that is what we are going to be using in this entire session. So socket programming is quite important, and that's why there's a whole dedicated slide just for this purpose. Right, so WebSocket provides a persistent bidirectional communication through a single TCP connection. Once established, the connection remains open for continuous data exchange. And interestingly, in our case, the model, which is Gemini Flash, the API, internally keeps all the care of the session history, the communication, everything. It takes care of all of that. So we don't have to worry about the conversational history and stuff. So here's how the direct connection looks like. The client has tools and authorization, which can be in terms of a token. We'll just have a look how that works. And then it interacts with the API, which our case is the Gemini Live API. All right. In terms of the Gemini API, not the Vertex one, it's quite straightforward. And like I mentioned earlier, this is intended for prototyping only. I mean, of course, when you try to implement it at a production level, you'll have to take into consideration the server, authentication, network security, and a heap of other things. So that is all a different ball game. So before we move into more depths of implementing these kind of real-time interactive sessions with Gemini Live API, let's see how we handle interruptions, because that's a very, very important part of any real-time conversation. All right. So while Gemini's response is being played back, we can interrupt. It gives us the full, it has the full authority vested with the user to interrupt anytime when the Gemini is speaking, and it will stop. So this will be registered by the voice activity detection module within the Gemini API. So interestingly, you don't need to program a different voice activity detection module. It's inbuilt with Gemini API, and when you are, let's say, trying to interrupt its generation process, it will understand that it has been interrupted and it will stop. Now, VAD will send a message back saying it's been detected an interruption, and then we need to handle it on the client side. How we handle it is our, it's our prerogative. In our case, we will handle it by stopping the current playback and then emptying the queue. In some cases, it may be decided to not empty the queue and let the Gemini API speak till the end of the conversation, right? Again, different ways to handle it, but interesting piece to note is that the VAD, which is the voice activity detection, is an inbuilt feature in the Gemini API, especially the live API. All right, so that was about Gemini. It gives the Gemini API, it gives us a, Dev API gives us like a high-level understanding of how it works, how VAD works, voice activity detection works, why WebSockets are important, why not REST, and then it builds the kind of fundamental understanding on top of it. Now, most folks here are from enterprises, big companies, reputed names, and when you build applications at that level, let's say you want to build a similar chat application which is specialized for your your customers or your end users, you would likely want to build it using Vertex AI, which is the enterprise alternative to this API. And when you build stuff using Vertex API, there are considerations in terms of, like I said, security as well as networking. So let's take a look into that. So the first thing that we will have a look here is proxy. Proxy is a very, very fancy and shortened name to call a server. It's nothing but like a middleware server which takes care of authentication and routing in our case. So for the proxy to be able to host tools, tools are another option which we can host. It takes care of the communications asynchronously, and there are a lot of ways to implement this proxy. Again, proxy is nothing but a middleware server which takes care of these interactions. So we can implement using the Python SDK, which is what we're going to showcase. We can also implement it directly in Python using WebSockets. I mean, we don't even have to use the SDK. WebSocket programming a little lower level, but if that kind of suits it floats your boat, then go ahead, you can do that as well. You can also do it directly using JS, directly with JS in the client. That's for prototyping purposes. You don't always have to use a server, especially for prototyping. It's an overkill. When you do that, you do the prototyping, you're comfortable with it. Till that time, you can also use JavaScript as a proxy handling service. So how does our proxy connection look like? So this is what it works like. So you have a client which has maybe tools, maybe it doesn't have tools. And then we have a proxy. It's a bidirectional thing. It's a bidirectional WebSocket-based proxy, wherein, in our case, in this example, in this demo, we'll just talk about the authentication piece, right? So the authentication happens through the it can happen through the SDK, it can happen through Google Cloud Authenticator, lots of ways to authenticate it. You may also do your own level of authentication by JWT tokens and stuff like that. And then behind that sits the API. So the API is at the very, very behind of this entire thing. So it's not directly exposed to the end user. It goes through this proxy. So it's like a high level diagram of how the proxy connection is useful and will work for a system like Vertex AI. And this is going to be our ideal state. I know in this demonstration, we may not be able to do all of this because this requires a lot of work. But let's just go through this diagram. There's a lot of information kind of packed into this one, but we'll gradually go through this diagram. So let's say we have a user interacting with this client through the browser. The request is sent, let's say, what is the weather in London, right? That's just one example. The proxy will take care of authentication, which can be through Dev API or Vertex API. Again, both are fine. And then there is a tool handler which has tools like weather APIs. Your own enterprise tools can also be there, like some CRM handler, anything like that can also work. That will interact with a couple of applications. These applications may be stored as Cloud Run functions. If you're not aware, Cloud Run functions are serverless small and kind of lightweight functions that can be run. It's all self-managed, so you don't have to worry about the infrastructure or the hardware. All you need to worry about is just to write your application logic and application code, right? And then again, it internally handles all the API key, secret management and everything. And finally, response goes back again to the tool handler. So everything happens within this proxy. So that's why it's the quote-unquote middle layer here. And once the proxy kind of formalizes what needs to be done, it then sends the data to the Gemini multimodal live API, right? As you can observe, we get information. Let's say the user is asking weather in London. Request goes to the multimodal live API. It understands that, oh, you're asking for get weather. So I'll just tell my tool handler to call the weather API internally and get the weather for London. It'll go back. It'll do all the interactions over here with Cloud Functions and return the response. And finally, the tool response will come back like condition is rainy, temperature is 8, whatever. And then final response is set back to the user. Now, a lot of people here in this room, in this auditorium, might think that why is a proxy even needed? For the case of Gemini, you probably don't need it because you can directly interact with it. But once you want to build enterprise applications, once you want to scale things, a proxy is needed because it is a layer that understands your business logic as well. I mean, that along with Gemini can supercharge your entire business logic and help you make really, really cool applications. So till this point, if you have any questions, you can ask me or you can ask Lavi here as well, because after this, we'll be moving to the actual demo. Yes. I can hear you. You can go ahead.
understand correctly, this is a typical agent call, right? And then where is the multimodality here? Because you're just making one request and that is going for one agent and then getting it back.
Yes.
So
Good.
where is the multimodal?
Good question. So the multimodality is in the request end, yes, but the diagram doesn't do justice. It doesn't show the multimodal part of it. It just takes a text as an input. But in the demo, we're going to see a lot of other modalities apart from text as well. All right, I think we can move to the demo now. So you can scan here. Here's the GitHub repository which we're going to be using. I'll give you a quick second or two to scan this, and I'll then move to the GitHub repo. Sorry. I'll just stand there. All right. So let's hope everyone has sign up for this. Let's just choose to GitHub. Okay, so this is the repository which has been created by a very dear friend and colleague, Hiko. So this repository is like a treasure trove of all the information needed to be built. And of course, this is more like a self-help, self-flow kind of information as well. You have like multiple parts: intro, dev API, Vertex API, different stuff over here. You can also use this and when you go back home, you can read about this. There's a lot of information over here as well. Of course, in the interest of time, we're not going to be discussing everything. We will just talk about a couple of notebooks and a couple of code samples that we're going to see. But if you want to go really deep, if you want to do a PhD and how this works, this is the place to be. This has all the information that you need, right? So this is like a guide. It has structures of introduction, WebSockets, with Gemini, with Vertex, different features and different stuff as well. Now, before we head to this, we also need to understand that for the developer work, I mean, in case you guys are not aware of it, we have something called as the Google AI Studio. Some folks here might be aware of this, some may not be, that's fine. So this is going to be this is basically how the end product should look like if you're building one which is very similar to this. This place is a one-stop shop for getting your API key and doing a lot of other experimentations as well. So this is like an example of stream real time, and this is exactly what we're trying to build as well. So I'll just go ahead and quickly show you how the actual product looks like, or rather this product kind of looks like. I'll just talk to Gemini. Hey Gemini, how are you today?
I am doing great. Thanks for asking. How are
Awesome.
you today?
Awesome, I'm doing good. I'm presenting at MLDS today.
That's great to hear. What will you be presenting about at MLDS?
I am presenting about you, Gemini.
That is quite interesting. Is there anything specific about me that you will be discussing?
So you can see that this is the application, and this is ideally and hopefully what we should be able to build by the end of this session. Of course, we may have different approaches, and that's perfectly fine, right? There's no one right way to achieve this. So before we begin, when you try to implement it at your home or over here, if you're trying to implement, you might need to get an API key. You need to kind of create an API key. This is the API key that you will use for the dev API, not for the Vertex, only for the dev API. So when you click on generate an API key, you can kind of just click over here, and it'll have a Gemini API over here. Click on it, and it'll help you generate an API key. So this key is useful for interacting with the API, the Gemini API, and see how it kind of works in action. All right, so without spending more time over here, I'll move to the fundamentals of the API and how we interact with the Gemini API before we move to the actual development piece. Okay. So this repository that I just discussed a while back, I have already cloned this on my local. So you will see a very interesting documentation over here. This is VS Code for those who may not be familiar. And there are a couple of SDKs and notebooks here. So in the chapter 1, as you can observe over here, we have SDK intro.notebook. That's the IPyNB, which is the notebook file. So we will first introduce the Google Cloud Gemini SDK and how it works. This is in Python. We have it in a couple of other languages as well. And for those of you who are interested, tomorrow my friend Lavi is also taking a session on the multi-agent workflows. He will also be taking and explaining this particular API in great detail, how it works and what all things you can do with it. All right. Also, another thing to note is the unified SDK. So very recently, we launched a unified SDK for Vertex as well as the developer API, which basically means that the SDK remains the same. There's just a flag that you need to set. If you set the flag, then it'll use Vertex project. If you don't set the flag, then it will use the developer project, which is the developer API key. So it's the one API, no need to take care of so many extra things. So I've already run this notebook, but for this audience, I can probably run it again, and hopefully it should work. So the first thing is setting up a client. And here's my GenAI client, and with an API key. Please don't steal it. It's OK, even if you steal it, I'm going to delete this anyways. So, so this one is the V1 alpha. And the Vertex AI parameter, if you can see, it's set to false, which means that it is a regular developer API. It's not the Vertex AI API. If we set it to true, which we're just going to see in a while, it will work as a Vertex implementation, which is the enterprise implementation, and not the developer API. So the developer key will not work when the Vertex flag is set to true. All right, so we'll first have a look into the text interaction. We have already set up model as Gemini 2.0 Flash Experimental, EXP. And the response modality is set to text. I hope this is visible to everyone. This should be good, right? Yeah, this should be good. All right, awesome. OK, so let's have a quick look into the code. Now, earlier in the age of generative AI and text LLMs, things were simple with REST, right? You just set up a client, send a request, get a response back. That's it, done and dusted. But over here, if you see, the connection is happening in a little a weird way if you think about it, right? We are using the async library, and this is Python, right? This is not JavaScript. So we are using the async library, and we are doing client.aio.connect.live.connect, and then specifying the model and the config. So there's a session variable, and that session, interestingly, is a bidirectional session. So always remember, in terms of live API, the session is not a unidirectional session, it's a bidirectional session, which means it's going to be listening to you or taking your input and generating output at the same point in time. It's not going to wait for one thing to complete in order to do the next thing. So it's a very important concept, and of course, if you read the API documentation, it will be clear. The message is, hello Gemini, are you there? And then we print the message, which is the input. And then we await the response. And we also send an end of turn variable, which basically tells Gemini API that we're done with this turn. We don't want to send something more. And then we wait for the response to come back, session.receive, and then just print out the chunk. So if I run this, hopefully it should run. So the thing is that with Gemini, this newer model, a lot of our customers are also using this day in and day out. So we do get out of quota issues sometimes. That's because it's so popular and so much in demand. So that happens often. So also look at the example of audio generation. In terms of Python, again, we're not come out of Python yet. We're just exposing the SDK and how it works. All right. So over here, we can see we are just creating a simple wavelib implementation. And this time around, we have a message which is in text. We're saying, hello, Gemini, are you there? And then we are kind of sending it. And then similarly, we are using an async method. We're not using synchronous response. We're waiting for the asynchronous response to come back. Because the session is bidirectional in nature, we have to use asynchronous programming. And personally, I was not a very big fan of asynchronous programming because I used to find it very confusing. But that now we've at such a point in time that everyone has to kind of learn it to use these things in a much more better and efficient way. All right, so when I run this and I just hit play, I've already run this. It just kind of generates an audio, and then I'm just using a converter to convert it to a pulse code modulated format with a bit rate of 24,000 hertz, which is the general bit rate. If I play this.
Yes, I am here. How can I help you today?
it goes ahead and plays that. So this is the basic fundamental aspect of the SDK. I wanted to introduce you to it because going forward, even if you build applications tomorrow, you would still need to understand how it works. And it's fundamentally a little different from what all you might have experienced till this date, because that was mostly REST-based. This one is socket-based. Right, we also have an SDK intro to Vertex AI, and I'll show you how similar it is. In fact, it is the same thing. We set up I just have my own project and my location, and I am setting up this over here. You know, it's already authenticated with Google Cloud on my machine, so I don't need to provide any credentials and anything like that. I just need to provide my project and location that I've already done, and then when I run it, it will go ahead and kind of generate it using my own project's ID. Yeah, so it goes there and generates, I'm here, what's on your mind today? And then, I don't know if you guys noticed or not, in the Gen AI client, the client remains the same. If you go back to the previous one and compare it with this one, the client remains the same. The Vertex AI is false, and we are passing an API key. Over here, Vertex AI is true, and we're not passing an API key, because like I said, it's already authenticated internally on my machine. You can also do it. I think you can just run some commands of gcloud auth login, and it'll take care of it. So this is the fundamentals of the the API client and how it works. Now let's take a look into the actual demo implementation. Yes. Sorry? Yeah, there is a few things changed here. In case you're getting an issue, this is just a very small thing. When you do a session.send, just define the argument input. Yeah, just define the argument.
Okay, fine.
Yeah, all right. By the way, this is all in preview right now. It's as we speak, it's being developed. Next time we meet, this may be like a totally different thing. So you're in the inner circle right now to experience all of this. All right, so this is the fundamentals of the SDK. Now let's move to an actual application. And the application is, the first Dev API one is actually built in JavaScript native. So show of hands, how many here are familiar with JavaScript? I know as ML people, we're not that much into JavaScript, but just a show of hands, JS people. Okay, perfect. So I'll try to explain it in a way which makes sense, and that's how I also try to understand. I am also not from a JS background, but I've tried to understand it as much as I can, and I'll explain it to you as well. So in the part 2 of the Dev API, I'll directly go to chapter 6, and I'll go to the index.html. So before we kind of go into the depth of the code and how it's going on, what's working on, let's just discuss at a high level what's going on in this piece of code. In this piece of code, we will be building a very, very basic UI, which has 3 options. One is a button to click on for the audio. The other one is a button to click for the video, which is my webcam. And the third one is a button to share a screen, similar to how you do in Google Meet or a Teams meeting. It's a similar kind of a button. So all of these 3 things are the 3 different modalities which are going to be useful and which are going to be used in our session. All right, so the thing about this API and the whole structure is that we need to establish a connection with the WebSocket. And the way we do it is that we just send a setup handler, which takes care of the modality. So we need to define the config and the modalities in the setup handler. We'll just have a look how it works. And then after that, we need to establish a WebSocket connection. We need to open a WebSocket connection with the API. Because this is in preview, there are some limits on how many parallel connections can be opened, but of course that is going to change as things move past. So let's take a look into the code. Though it's JavaScript, but I mean logic remains the same. So let's try to kind of go ahead and look at it. So let me first show you how the UI piece looks of it, so that you're kind of interested in it. And I've already kind of run it on my local. So I'll just go back. So part 2 Dev API, chapter 6. So it's a very simple thing, right? Like I said, we have one button for voice, one for video, and one for presenting my screen, right? So this is how it's kind of going to look like, and we'll see it in action as well. But let's have a look at the code first. All right. So we have buttons, like we discussed, like toggle microphone, webcam, and screen. And then we have event emitters. All of these are defined. audio recorder, audio streamer, and media handler. Because anytime you have any audio input from your Google Chrome tab or Microsoft Edge tab coming in, you need to process it in a particular way. That's what these takes care of. These files take care of. And by the way, all of this is already there in your, it's already there in the code repo. So when you take a pull, this is going to work as it is, right? You define a API key, which is, I mean, of course, without that, we can't do much. And then there's also a constant, I mean, there's a constant variable, constant which we've defined over here, which is the actual API. It's the generative AI languages, Google APIs. And the endpoint is the one which we're going to use. So the endpoint, if you see, if you observe over here, it says it's a BIDI generative content. BIDI stands for bidirectional generate content. So it's essentially a bidirectional way of generating content like we just discussed, right? So then we have a couple of stuff over here. We have a Gemini Live API which we have defined, which is just another JS file which takes care of a lot of things, including interruptions. And those are very interesting. I'll just take, in a while, I'll just explain why they're so interesting. So you have all the socket programming handled over here, along with the interrupt handling. And how does that work? Apart from that, then we have stuff like audio initialization, then audio chunk, playing audio chunk and pausing audio chunk, recording, as well as taking care of the webcam. Yep, so toggle microphone, converting it to a buffer, and toggle webcam is also there. All of this is already handled, right? We have toggle webcam, we'll turn it on, turn it off. We can ask, you know, what's going on around me, around you, anyone. And then also we also have this last thing of toggle screen. Now, like I mentioned in the just a while back, it's very important that we send a sequence message, I mean, a startup message before we kind of start processing the whole thing. And we've handled the entire thing in the Gemini Live API. So the Gemini Live API takes care of, you know, the default setup and everything. If you kind of see this, we are taking care of the default setup in Gemini API. See this? So it's taking care of the default setup. We can specify the name. The voice name is Puck. And the response modality is set to audio. I mean, it has audio as well as text. And the model, everything is defined over here, generation config and stuff. And before we kind of send the output, we will have the, we'll have to kind of define this over here. And once we are able to put everything in place, again, this is only for development, because if you observed a while back, I have actually put my API key in this file over here, which is basically an HTML file. This in no way is something that you should do in production settings, right? This is just for prototyping, internally developing something, because this is a free to use key, right? It doesn't have any, it has some rate limits, but it's free to use. You can quickly develop with stuff. All right, so if we run this and hopefully go here and just refresh this, let's see, all right. Hello, Gemini.
Hello. How can I help you today?
I'll present my screen. Can you tell me what's happening? I'll turn my webcam, yeah.
Sure, okay, I can see you now. You are in a room with a poster behind you. Do you want me to describe anything else?
What do you think I'm doing in this room?
Based on the video, it looks like you are presenting or speaking to an audience. There's a slide visible behind you that says Gemini Multimodal Chat. Is that accurate?
That is accurate. Thanks a lot, Gemini.
You're welcome. Is there anything else I can help you with?
So just like this, we can also kind of present my screen. I'll start again recording. Hey, Gemini.
It sounds like you are having some trouble. Is that correct?
Yeah, I want to understand what this repository is about.
Certainly. This GitHub repository, named Gemini Multimodal Live Dev Guide, appears to be a developer guide for Gemini's Multimodal Live API. It contains various files and folders, including documentation, examples, and code related to the API. Would you like to know more about its structure?
No, I think that's enough for now, Gemini. Thank you.
All right, you're welcome. Let me know if you have any other questions later.
So this is how it works.
Okay, I see the Insights tab is highlighted.
Let me just refresh it. Right. So each time we run it, there's some things which are logged over there. It tells you when the session is started. Again, this is just for debugging purposes and it's just to make it a little more interactive while you're developing it. It tells us the information about like when we are starting. the session and when we are presenting something, and if the Gemini API is responding back or not. So all of these things, like you saw, it's very straightforward to build. But over here, this is just for prototyping, and the entire code base lives within the it lives within this HTML page, including the API key. So once again, do not use it for production. This one particular thing is just for prototyping. All right, so you saw how basic and how straightforward this was to implement this piece, right? We just have a couple of, couple of JS code, and we kind of use it to stitch the entire application together. Now, I know that most people here are in enterprise-oriented folks. JS is definitely not one of our first preference of programming languages. So we will talk about the Vertex AI aspect of it as well. Now, moving forward. So in the Vertex AI aspect, we definitely looked into something called as the proxy. So we will spend some time to understand how we define this proxy and how does it work, and what's going on actually within the proxy. We'll spend some time because this is going to be the heart of the programming paradigm if you, say, decide to use this tomorrow in your application. So let's move to this one. Yeah, I think. So any questions for the dev API? Let's take questions, and then I'll move to the Vertex one because that's very different from this one. Yeah.
That you have, in this case, you're handling multiple interrupts, right?
Yes.
There are at least 3 of them that you'll have a handler for. But there could also be interruptions from the browser. Like, say you do a refresh. Now, how do you handle that?
Good question. So at the moment, interruptions are only handled, and I think I'll just present the demo on this. Thank you. You reminded me to do that. Interruptions are only handled at a voice level because internally in the Gemini API, there is a VAD, which is the voice activity detection, and it works in a very interesting way. The way VAD works over here is that it continuously, of course, listens to the conversation. That's how it works. But then the moment it's generating a response, and if it hears a interruption, let's say if it's generating something, this is a repository about this blah blah blah, and I say, okay, no, I don't want to hear this. So the VAD module is parallelly running in Gemini. It's going to send a signal which will say that interrupt. So then, how do we want to handle the interrupt? It's totally up to us. That is a choice of the end user. So in our case, the way we handle interrupt in this application is we're going to clear the buffer and we're going to stop it from speaking. But in some cases, you may want it to let it complete first. You can do that. That's also possible. Now, the question that you asked is, what do we do in case there's a tab change or something like that? At the moment, this is not handled directly because the interrupt is only voice activated. So let me just show you an example of that as well. Let me just refresh this. Hello, Gemini. Can you tell me a really long and boring story?
Sure, I can try to tell you a long and boring story. Once upon a time, there was a very ordinary rock. It sat there for a very long time, doing absolutely nothing.
I think that's enough, Gemini. This is getting quite boring. Thank you.
Okay, I understand you've had enough of the...
So this is how it kind of works. The way we've handled it in our code is, you're going to speak, and the moment I speak and it's speaking, I'll show you the code as well. There's an interrupt flag which is raised, and it's up to us how we want to handle that interrupt flag. So if you see over here, so the server content response has a flag of interrupted, and when the interrupted flag is raised, we can handle it however we want. And because it's a session which is a WebSocket, it's happening in parallel. And it's asynchronously, it's like you can have a separate thread on which this is running, so you can handle all of these things parallelly. All right, so we were taking questions.
I have a question here. So how do you, manage the diarization here?
Sorry?
The diarization. So multi-channel, single channel. Say two people are talking together, or 3 of them are talking together.
Good question. So the way it works is that if 2 people are talking together, Gemini as an API, it's actually built to have a one-on-one conversation with the API. But if 2 people are talking together and there's like a difference in the voice signatures, it takes care of that internally.
I'm just trying to tell you the setup of the conference call, right? So how do you diarize that?
Okay, so in terms of a conference call settings, directly there is no diarization because the intent of Gemini is to be like a one-to-one assistant. So it's like you and you plus the AI model. if it has to be kind of diarization aspect or has to be introduced, then you need to present the screen. Right? If you present the screen and give that audio to Gemini along with audio, so it can understand, okay, this box is highlighted, so this person is speaking. So it needs multiple modalities of input in order to diarize things. And of course, it can be handled using programmatically. It's not a native feature at the moment.
Thank you.
Yeah, I think we have a question there, then I'll come to this side. Sorry? Language, yeah, I think it handles a lot of languages. Natively, it handles couple of dozen languages. If I start talking to it in a different language, especially like Spanish and stuff, it sort of responds in that language.
Hindi or something of that sort.
Yeah, it can do that as well. It can do that because it's a language model in the heart of it, so it takes care of that.
So one question on this, we actually clicked on that camera and everything, right? So is there any way we are giving it the consents also, like consent to the user, like automatically? Actually, it's a data privacy concern here, right? So
Yeah.
where exactly in the code I couldn't see anything as authentications, right?
Good point. So there are two levels of consent which are generally there. The first level of consent is at a code level, like you mentioned, that we are going to be presenting, your screen. You can handle that can be handled using, if I am building it's an enterprise application, I'll take care of that at my own level. The second happens at a browser level. I don't know if you observed when I started presenting, it asked me, do you want to give access to your webcam? And I had to give the access. So if I deny the access, it won't get the access.
This is supposed to run on edge devices or else on devices, right? So how do you handle latency?
So the way this, very good question by the way, it's a little technical, but the way it works is that regular regular LLMs, right? They wait for the entire input and then generate. Gemini Live doesn't work like that because it's an asynchronous module. It sends data in chunks. In fact, I think I don't know if I have that piece of code here. Maybe I have it here. So here I'm sending the entire session information, but when you see the code for the proxy, which I'll just show in a while, you'll see that data is sent in chunks, especially when I'm doing audio interaction. So even before I'm ended my conversation, it's already processing stuff. All right, and I can define the limit. So of course that limit has to be how many seconds worth of chunk needs to be sent. In our case, we define it around 500 something milliseconds. If the second duration is increased, then it will kind of take longer to process, right? Because a lot of information. But if you decrease a lot, make it very, very, very small, like 10 millisecond, 5 millisecond, then the overhead of I/O is a lot. So it's a trade-off. But it actually processes because it's a bidirectional client and it works in asynchronously. It's already processing the chunks even while you're speaking. So that's why it is so fast. It almost feels real time because it is processing in almost near real time.
So
Attention?
attention is all you need. The seek ahead, because it's processing every 0.5 seconds. Won't it influence the outcome?
So good point. So there's a lot of other magic happening under the hood. Attention is definitely all you need, but now there are other things as well which are built on top of it. To be honest, this is more of a this Flash 2.0 Flash is more of a interactive kind of assistant, and also it has like deep knowledge of the entire thing. So the entire aspect of it, it doesn't get affected by it. The reason is it has a something called a session memory. So let's say if I'm going through it and I'm interacting something, I can ask it in the next step to summarize the thing for me, and it does that because it has session memory. So even if it has kind of missed something in that particular thing, by chance, it has the entire context now. So next time you ask, it'll just use the entire context. So it takes care of it that way. I think you had a question. I think we should give him mic now. He's waiting for a while.
So how do we augment, any corporate data? Because Flash might not be aware of certain things that when we show or something.
Good point. Good point.
How do we augment?
So in this repository, there is something called as function calling, which I don't think I'll be able to demo now for two reasons. One is time. Second is that it requires certain API information. But then Gemini has a very, very huge, token limit. I think what is the limit, Lavi? 2 million, right? It's around 2 million limit. So imagine this, like you saw the diagram, right? When you have Cloud Run, imagine your corporate APIs and everything are sitting down there. Everything, some request is coming, you can just pull up data from that or format it into a JSON or a nice YAML or a protobuf or whatever, and then push it to this API, the multimodal API, and then start sending the information. And interestingly, you can do that again in chunks. You don't need to fetch the entire thing. So you can optimize, there's like no limit to optimize the flow of this. Yeah, there's a question. I think.
Here. I have a question here. Basically, two questions combined on your left.
Okay, sorry.
So, the first thing is only Gemini 2.0 Flash can give multimodal outputs, right? Not Flash, not one or not two.
So multimodal live only 2.0 Flash. Multimodal in general also, yes, you're right. Multimodal general also only 2.0 Flash can give.
Okay. So this is not live yet.
No, this is live, right? We saw live having conversations. Yeah.
So the other question I have is we use Vertex in our live production applications as well. What we faced is to keep up with the developments in the Vertex.
Developments.
Yeah,
Okay.
it's regularly, constantly
Oh,
changing.
okay, like
right?
updating.
Yeah, updating.
Okay.
How do you take care of this internally? You might be using Vertex AI internally also, so that I can take some points and use that.
So what I would say is that build applications agonistic to the, things are changing very fast. So you need to build applications which assume that this thing is going to change very soon. So everything, whatever you can put in a config, put it in a config. Don't hard code anything or don't assume that this is going to be the same tomorrow.
Yeah,
So
I have seen the base parameters itself getting changed
yeah,
in 10-15 days difference. So
that's yeah, that happens sometimes. Yeah.
thank you.
All right. Just a few more questions. I think we have one over here and one over there, and we can move to the Vertex implementation.
How
Here,
does
over
the
here.
how does the audio engine process the information that is given to it? Would it convert whatever that we speak to text and then process it, or would it take the audio as it is? For example, can it understand the emotions that we speak with, or can it just convert that to blind text and process? Can it understand if I'm humming a music without any lyric at all, or do I want to explicitly speak for it?
All right. So Gemini, the Gemini family, especially the 2.0 family, it's trained as multimodal from the scratch, from the very base of it. It's trained in a multimodal data. So it's not converting into text. Because of the way it's trained, the data itself has video, audio, images, text, everything together. So there is a good chance that if it has seen those range of emotions in its training data, it will be able to understand that as well. Though that's something which is a good point to test maybe.
So my question is, can it use the video and screen share at the same time with the recording?
Yeah, absolutely.
So can we use these three data to detect something like someone is giving interview to? Can we use this to check if there is any cheating or there is any deception or something like that?
That is a good use case. I am not sure about the ethical implications, but that is definitely a good use case to check out for.
Okay.
While using the API, we use this safety settings.
Yes.
Block few, block
Yeah.
some, block none. I couldn't see any safety settings, so there must be some default that is getting used over here. So which is the one, and what kind of blocking it makes? If I ask some question regarding, let's say, biology, would it block that? I mean,
So safety settings need to be configured as a config. We are not providing any, so it's taking the default ones, which I think is default is block some. It's not block none. It is block some. I'll need to check on that, but it takes default if you don't specify. But if you want to specify, you can just specify in the config here.
okay. And if we do block some the highest level, all some things there, but if I ask very basic question, then also it blocks those things. So have you experienced, I mean, how to cope with that?
So in my experience is that if you, some things are like, if you do block all or block, the highest level of blocking, then it will just do very basic interactions. Right? It will be like a kind of a safe paradigm for, it will not answer questions regarding to health, right? especially about physical well-being and stuff, it will not answer those questions. It's like a dangerous waters for that blocking setting. But you can define the blocking setting. You can, there are like parameters within that. Like, is it abuse? Is it, adult images? They have like different parameters. So you can tune, you can specify which one to block, to with what intensity and what limit, and it will block just that. So it's use case specific. All right. I think there's one here. Let's.
Okay, so right now in the JavaScript front end you see, so let me say I have 1,000 pages of PDF, okay. I want to talk to it so that some questions will be answered from the PDF and there are some diagrams are also there. I want to display the text. So basically I'm giving a voice input, I'm asking to display a diagram.
You're asking to create a diagram?
Yes, and generate the diagram out of the context in the PDF.
Yeah, I think you can generate a mermaid diagram, but you can't directly generate like a diagram out of it yet.
Okay, if there is an already existing diagram in the PDF, will it be able to display?
So Lavi, you want to answer that? He's saying is there already diagram in the PDF?
But you want to generate the same diagram or?
No, for example, that says that there are some stats of that saying that Bihar, these are the things happened, in Karnataka, these many happened. If I ask, okay, compare Karnataka versus Bihar and depict me the picture which is in the PDF. That is one existing one. But can it generate? He said generation no, but if can it depict?
It'll depict in the textual format in the audio saying, hey, I saw this and it said this, you can go to page number this and all of that. But it'll not generate the images, but you can actually ask it to generate the mermaid code, which will then create a graph and all of that. So it's almost like saying generate the code for the graph and then copy and run that graph.
But if there's an already existing image in the PDF, that
it'll just do the reference to it saying, hey, I saw this in the page number this and this, you can go and check that.
Okay.
So it'll do that.
Okay, thank you.
Can we take the question?
Yeah, can you take his question? Yeah, that's also fine. Correct.
I just wanted to know, how do you process it? So for example, if I ask, hey Gemini, what is there on my screen? Oh, no, never mind. What is the weather today? So now if you process it into chunks, so what is there on my screen comes first, and then, oh no, never mind, just let me know the weather. So what happens? Is this proprietary or is it open? Is this information
internal.
open for okay.
So do you see this? I'm just presenting a piece of code.
Okay.
When you see this, right, we are sending an audio chunk. So we're directly hitting the API that we have. We're not sending it the entire audio because that's not possible, right? We don't have the entire audio before it's spoken. So
one more thing, are you handling over here or is Gemini API handling this?
So Gemini API doesn't differentiate. If I send the entire thing to Gemini, sure, that will work too. I can just make a long speak, hey, I want to do this, do that. It'll hear the entire thing and process it. But the latency you'll face there is going to be immensely higher. And that's a suboptimal way to do it. Conversations in terms of live API, this is the better implementation because it's more conversational. So here, if you observe, here we are actually chunking. Even if I'm speaking continuously for let's say 10 seconds, it's going to make chunks of half a second each. So 20 chunks it's going to go and create, and then it's going to send. So while I'm let's say speaking chunk number 10, it's already processed till chunk number 8, right?
But again, for the use case that I just said, that what is happening on my screen? Oh, never mind. Just tell me the weather. What happens this?
Oh, that way. So that way, that's an interruption. What you're talking about, right? That's
not an interruption. It is the same audio. So
yeah, it'll just ignore that basically. It'll ignore
because
that, right?
Imagine this to be a pipe, right?
Yeah.
So it's the chunks are going. It doesn't do any action until you stop or you create an interruption. So you might say 10 different things, but whatever the last question that you're trying to ask it, or it'll just summarize the overall thing that you said. So a lot of time people have like 5 things that they want to ask, right? Hey, I'm going through this PDF. I want to know this, and this. So these are 5 different questions. Because it has that pie where all the chunks are going, it will figure out all this and it will answer all this in a single go. So unless you interrupt or you stop, it will not take that action in that moment.
And you're handling this on a code level?
On the code level. If you want to handle it. Otherwise, it's just happening on the back end.
Got it. Yeah. Thank you.
All right. I think we'll move to the... Okay, sure. Sure, and then I think we'll move to the Vertex piece. And then we can take combined questions. Yeah, please go ahead.
are you getting the history of whatever the conversation history here, like what we asked?
Yes.
And
Session history is maintained.
so it is stored in the GCP, like where it's stored.
Okay, good question. What I read from the documentation, this session history is stored for that session. It's not ephemeral. Sorry, it's not permanent, it's ephemeral. It's just available for that session. If you want to store it, the onus of storing is on you. It is the session history is alive till the session is alive. If I kill the session, or let's say the server, I mean this I'm talking about a WebSocket session.
Yes.
The moment the socket session dies, it is up to you to preserve the history.
History of audio, the screen shared.
Everything.
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 Will be there.
It will be there, but if you don't preserve it, then it's lost.
Oh, it's up on us to.
It is
store
on us.
on
At the moment, it is on you to preserve. Within that session, Google preserves.
Okay.
But the moment the session ends, it is on you to preserve.
And one more question: what is the latency to respond to the user query? If
So
you say hello, what?
Latency will depend on a lot of factors, right? The token length, the complexity of the question. There's no one
Okay.
one
Okay.
answer to that.
Okay, fine. Thank you.
Just to add,
Yeah.
the history is maintained in the token format. So it's not like there's a screen recording which is being saved or the video is being saved. Every session that is being saved during that particular session is just the token session. So it's not like you can actually reuse it and say, hey, what was that guy doing in that? It's a
Oh, okay.
token, right? So you can use it just with the model. You can't say, oh, give me all the videos that were stored or something like
No, yeah,
that.
that's what. If an end user is using this application and he want to see what he the conversation, we can't represent the.
Correct.
Yeah.
There's no representation in the way you understand it. It's in the token format. All of this is being saved.
Except the audio, because audio we are
Except
already.
the audio.
Yes.
But even those are saved in token. That's why he converts that into the WAV format, right? That's,
Yes.
If you saw, he was showing you that, right? So everything is tokens.
There'll be more work if you want to reconstruct
Yes,
the.
yes. So you would have to create the persistence layer accordingly, and then if you want to save it, you want to save the video, whatever that you want to save for whatever purposes, you would have to create that layer.
Correct.
Okay, fine. Thank you.
Right. Awesome. So now let's move to the Vertex piece of things. So with Vertex, we I think discussed the proxy. We'll just have a look into the proxy and how it works. What is differently happening in the proxy? In our case, the proxy is written in Python native, and we'll just have a look into that. Okay, cool. So here's the proxy code. Like I mentioned, the proxy is responsible for authentication is one, but it is also responsible for actually handling all the input and output stuff. So instead of the app directly interacts with the Gemini API, it will interact through the proxy. So for the proxy, let's take a look at what's happening over here. We define the host and we define the service URL, which is just the bidirectional generate contact URL. There's a simple method that we've generated to get access token. This is for authentication, like authentication of Google, the Google Cloud project that you're using. And then if you see, there are two proxy tasks created, which is basically a WebSocket protocol-based task. So it forwards messages from one WebSocket connection to the other. One is the input task and one is the output task. So imagine just, you can imagine two connections open in the same proxy, and they're bidirectional. So one is going to be the input, other one's going to be the output. That's going to continuously be, polling for that information. So as you can observe that it says, async message in source WebSocket, try to do this, which is like push it to audio video input or inline data or setup message, depending on how the input looks like. Or else, you will also have a target WebSocket implementation, which is actually sending the data back to the response. So it is handling the two things parallelly together. And of course, it's implemented in a async await method. So it basically is running concurrently. All these exceptions. So we also have like a create proxy. And this is the main brain of this entire proxy. So when we say the create proxy, we are basically creating tasks. When I say tasks, they're like socket-based tasks. One proxy's task is to take inputs from the user and determine its modality. If it's text, audio, video, webcam input, that's one proxy. The other proxy is working with Gemini. It's kind of taking the output from Gemini and processing. Let's say it's an audio, so you need to process it into a streamable and playable audio format. How do you do that? This proxy kind of takes care of it. So if you observe, there are two proxy tasks, client WebSocket and server WebSocket, which is like client to server and server to client. And then of course you're waiting for both the tasks to complete before kind of closing this session. So we have a client WebSocket if you just observe, which is defined over here. And then there's also a custom client WebSocket, and the other one is the user WebSocket. Both of them are working parallelly. And finally, we have cleanup connections. If that thing is stale, if the connection is stale, nobody's interacting with it, you can just bail out of it and it'll stop working. Now in the same repository, we have code to actually Dockerize the entire thing and push it to Cloud Run. But in the interest of time, we're not going to do that. What we will instead do is that we will just self-host this proxy locally on my laptop and then see what happens with that proxy, right? So let's just try to do that and hopefully it should work. So let me just move to the other tab. And let's see. So there's a proxy is already running. I'll just run this Python 3 proxy. And it is asking me, do you want to let the app to accept incoming network connections? I say allow. So I'll wait for the proxy to start. I think it's already started. So the proxy is also running on the same server on the 8081 port. So now I have two apps running. One is the other application, which is just the web interface. And then this is the proxy. Let's take a look into the code. Let's take a look into the demo, and then we'll come back to the code of the actual JavaScript, how it implements this particular stuff. So let's just go back to this one. This one, yeah. Let's go back here. Let's go to Vertex API and chapter 10. All right, so you observe when I kind of establish the connection, this is unclickable for a while. That's because that is the time where the setup is happening. So like I said, setup is basically just an initial, an empty request. It's not an empty request, there's a particular format you can read in the documentation, which goes to the server and says that, be ready, there's gonna be a connection coming your way anytime soon. So this is the kind of client setup. Hello, Gemini.
Hey there, what can I do for you today?
So this implementation that you just saw, this is through proxy, and I've changed the audio to another person. So there's a couple of voices that you can select. I've selected a different voice. So this one is happening through the proxy, and if you actually go back to the code, which is over here, you can see the actual logs over here, which is what we should be doing. So I'll just show you this one. There you go. So you see that this turn is, so you can see the actual logs of the entire thing which is coming, right? You can see that the user is speaking, that is myself, I'm speaking. Turn complete is false, it's continuously user speaking, user speaking. So these are all the chunks that we just talked about a while back. This is how it actually looks like in code if you want to print it on your server and backend. For debugging purposes, it's a great thing to do. And this will do all the way up till, it's a client content which is coming up. And then parallelly, you can see that the user's input is taken and then the output will be generated. So connected to Vertex AI, the voice message is AO'd and then we'll start generating the voice message. It says setup complete and then start generating the voice message. So I'll just show you something. See, so where user, yeah. So when the turn complete gets to true, which is when I'm done speaking, then it goes ahead and sets up a forwarding client to the proxy, which is responsible for generating the actual output. And that is what is running in the Vertex AI front end. And now let's take a look at the index.html for this particular case, which is the front end, and let's see how we have interacted here. So over here, we are not specifying any project, any code in terms of access tokens or anything. We are simply specifying the proxy URL, which in our case is localhost because it's running locally. If you have a Cloud Run instance or a VM on which this is running, you will specify the website or the address of that VM. This is my Google Cloud project and this is the location. That's it. The authentication and all is not the headache of the front end. It's going to go back to my backend, which is in my case it's just my server which is running locally, and they'll take care of it. So you can imagine when you build an application like this, your authentication is offloaded to your server. Your front end doesn't have to worry about if it should go to Gemini, if I should rate limit it, if I should pre-process it, I should do whatever I want to do in the backend. So this is how you actually develop something at a larger scale. And then you just specify a setup config, which is, like I mentioned, setup is something that you need to do before you call the API, simply because the setup defines and prepares the server to get ready for this. So the response modality is audio. It can be audio or even text. Text can also be a valid response modality. And the voice name is Eod. You can also say Puck, or there are a couple of other voices as well. You set up the model and stuff, and you initialize the API. Again, same code that we use for JavaScript. And then that's it. And then you just take the input, play audio chunk, process audio, process input, and everything else remains the same basically. You just have the same containers, same audio handlers and stuff, which are responsible for just taking the data and sending it to the backend, and then the backend takes care of setting up the proxy and handling the connection. The good thing about having a backend proxy is that you can also rate limit stuff. You can decide how many connections do I want to allow, and what should be the connection level, and how much information, how much tokens can be passed. You can limit everything there as well. So that is also an advantage. And finally, in this same piece of code, you can have this. Everything else remains just the same, and we can develop the same particular thing. So this was for Vertex, and let me just move back to the diagram again. Right. So now you can kind of imagine and you can put the entire picture together, right? The proxy is handling everything else. The front end is handling the processing of the input, audio, text, video, as well as your screen share. Everything is responsible. Of course, that JavaScript handles it at a client level, at the client level, at the Chrome client level. And at the back end, the proxy handles the entire processing in terms of authentication, rate limiting, deciding which flow goes where, and also interacting with your internal agents, let's say weather agent and stuff like that. And then finally, it sends the input to the multimodal live API, and you get the response back. There is a little bit of processing required, which helps get near real-time outputs. Again, it's not mandatory you do that, but if you do that, you'll have the best response time than latencies. If you don't do that, then it's going to take a very long time to generate the same response. All right, I think with that, we're almost done with the session. We want to take some few questions, and then we have some things which we want to present. Yeah. So tomorrow we have one more session with the for the multi-flow agents, multi-agent workflows with Lavi. So you should ideally, if you can, bring your laptops with yourself, and you'll have a lot more fun, I believe. Yeah, I think somebody had a question.
So couple of questions. If you can answer them in a synchronous way, that will be great. So I'll ask the first question, which is, if you want to restrict the conversation to a particular topic only, how do we do that?
Good question. So in the config where you specify, when you specify the entire thing, right? You specify the safety settings. You can specify the temperature settings and everything. You can also specify a context, like a preamble or sorts. That is how you can do it. And then internally, if you're using something like a proxy or something, right? The advantage again of using that is that once you get the response, you do not immediately need to forward it. You can just take the proxy, do your own processing in there. You can have a simple regex or another model, the very lightweight model whose job is to say that, oh, is this relevant or not? And if it gives a thumbs up, ship it out. If it doesn't, then don't ship out the output.
Yeah. So brilliant. The second follow-up question to that is, whenever we've been doing red teaming exercises with GenAI, chatbots, conversations, what we also find is that because there is a long-term memory and a short-term memory, there is this big risk of memory poisoning. And because of which, typically, if there's a bad actor, they can actually steer the conversation towards something that is not relevant to the topic, in spite of defining the context. So have you been able to address that aspect in some form?
So when we, cloud customers kind of face this thing, we generally advise and we generally build using something, you may be aware of Dialogflow, where you can control the intents. So what happens, it adds a little bit of latency, yes, but it's not one single model. It's like a host of different models, attacking the problem from different sides. So if you try to steer contents in a different way, there are intent detection models that will just not allow that to happen. So that is a more production/enterprise centric way. That's a good point, but that's how you generally should do.
Thanks. Thank you.
I think we have a question here. Just give me.
Sorry.
No worries.
Yeah, hi. Just wanted to understand the performance trade-off you all are doing in terms of accuracy maybe, or in terms of latency. I think you talked about latency a bit, but maybe resource utilization or accuracy, like how do you all try to handle? Is it from the training model itself, or does it come from the code which you were showing?
For the accuracy, I believe it will be from more or less from the training model side, like where it's trained, which is the research, the Google DeepMind. Um, but the other thing is that when you're trying to answer very topic-centric questions, like the gentleman over there asked, if you want to ask and get responses for very topic-centric questions, then it also depends on how you define your system. Are you able to catch false positives? It's not just a model, it's just the entire whole ecosystem around it. Are you able to catch the false positives? Are you able to preemptively prevent some malified prompts to be injected in your system? So that kind of system, that's like a system level thing. But for just the LLM, if you're asking, that is something that the research teams look into.
And also just to add, we have not opened the tuning for this as of now. I think tuning will play a great role in making it more accurate for your business. I think that's going to come eventually.
Soon,
it's
yeah.
not there on the recent plans. That is one. The other is you do have system instructions, so which means that you can actually make it more customized. You can do few short examples and make it more sort of adhere to your custom sets that you're trying to do. So these are certain things that you can control and adhere it to the domain that you have. But tuning will be something that will make it more accurate, which will come eventually.
I think you have a question. Yeah. Mhm. Mhm. So that's a very interesting point of view. That's also depending on how you design the system. Definitely, if you're, let's say, asking a question to it, let's say you ask a long question, and I would assume that Gemini has already kind of generated response, it's just waiting for you to start speaking, and it starts speaking, and you kind of stop it. So how you handle that interrupt is totally up to us. So in our case, we are kind of just clearing the buffer. We don't care about all that. It still is in the session history, because session history is something which is maintained by Gemini, not by us, as in not by the application, right? But let's say if you want to know something and you don't want to, you want to interrupt Gemini, but you don't want to stop its current thought process. You want to hear what it wants to say, that you can handle it. So instead of clearing the buffer, you can actually let the buffer play out and then let it play the next set of output. So that you can handle it. So it gives you a flag called interrupted. It sets the flag true the moment it detects interaction. How you want to handle it, it's totally up to the end user. That's flexible. So buffer in your local application will be removed, but the actual Gemini's session, it will still be there. So if, let's say, it has analyzed something, it's very hard to say what it understands because it hasn't spoken yet. But let's say if it has analyzed some very complicated thing and you again ask it, it will basically understand, oh, you already had asked me this. You can ask it, can you summarize? It will even tell you, oh, I generated this and then I got interrupted. I generated this, but till this point, and then you kind of interrupted me. So then I stopped generating to that point. It knows that it has been interrupted. Yeah?
I have a question about
one question, yeah.
about the tokens. So these are multimodal, right? But does it mean that text, audio, and video tokens are same?
Sorry, I can't hear you that well.
Okay. This is about tokens and their pricing. So these are multimodal, text, audio, and video, right? But they are priced differently, right? Or are they same?
They're priced differently. Good question. Are they priced differently? Right now it's in preview, so there's no price right now associated.
Okay.
It's in preview right now, multimodal API. So there's no pricing associated. Once it goes to generally available, that time I think they will decide what the pricing will be. Yeah, Pricing is based on tokens, not on the modality. So the thing is that a video once, let's say 1 second worth of video may consume X amount of tokens.
Okay, okay.
Right?
Yeah.
It's token specific, not modality specific.
Okay, so let's say for like small chit chat and all, like hi, how are you, this kind of things, right? I mean, it's okay if it's audio or text. So doesn't mean that it's better to send the text by ourselves, right? If I do the speech to text.
Oh, you mean like that?
Yeah.
That's a good. I mean, you need to analyze that. Of course, if
just
you
to
just send.
make it more affordable or something, right?
Yeah. So the thing with text is that text is always going to be cheaper, right? Because lesser processing.
Yeah.
Right. But the user experience goes down. If it's just text as opposed to audio interaction, user experience goes up. So there's a lot of things. Plus, if you're presenting your screen, presenting your webcam, text, it's very difficult, right? You're presenting.
Yeah.
Imagine you're presenting your screen, you're typing. What do you see on my screen? So it does a lot of factors. There's also a user experience factor, Matt, coming in.
Okay. So the total cost would be always with tokens.
With respect to tokens, yes.
Okay. Okay. Thank you.
Yeah, I think. Yeah. Go ahead. TPUs. Google's proprietary models run on TPUs. They're built accordingly, correct.
And so I'll be built accordingly. So, okay, like for example, we are mostly on AWS. So like we use certain things like AWS Trainium or Inferentia. Those are specialized GPUs which are highly cost effective.
Okay.
Do you have something? I'm sure you have, but then can we configure those instead of running it on any GPU or TPU, which can be more expensive?
So any of the open source models which are available in the open market can be run on any hardware. As in GCP has a lot of hardware offerings, like we have A100s, H100s, even TPUs are there. So it's a matter of the developer's preference on which they want to run. But Google's proprietary models, they run on TPU, and that is also the reason why the cost of generation, Google is I think the cheapest in the industry at the moment.
And that's an abstraction to the developers, right? We don't need to really tinker with what infra it's running on.
For TPU, you might need to tinker with not with the infra, but with the code, because TPU is XLA.
Okay.
It's a little different.
Okay, got it. Thanks.
One more.
Yeah.
Yeah. So I just want to understand like where all the source data come from. So whenever the question is received, it could be from different domains like medical science or food or cooking, or it could be movies or anything.
Yeah.
And when the question is completed, there could be like when the Google search engine or any search engine works, we might have 100 to 200 results. So how is the like algorithm understanding like which is the most accurate and legitimate one?
I think that's a very interesting question. That's the power of large models. It's also how attention works, and there are internally there are a lot of algorithms which kind of theoretically rank which is better and which is worse, and of course there's a lot of testing which happens internally we have RL and a lot of other mechanisms which kind of continuously upgrade and make sure that the most relevant information is displayed. However, that's not like a foolproof thing. Errors may happen, but there's a lot of algorithms running under. It's not just one large language model. It's like a whole host of other things. Continuous pre-training and all those things are happening generally. Yeah, I think you had a question this side. Oh, you had, okay.
Yeah, for a specific business problem, as he said, you said we can use system instructions and also use few shot prompting as well to increase the accuracy. Can we also utilize RAG in this case?
We can, yeah, why not? That's a good idea actually. Because the context, see the thing is that if you want to use RAG, it's definitely good at lookup. But with Gemini models, the context itself is like close to 2 million. It is 2 million, not close to 2 million. So you can essentially, if you have a lot of data, you can just pass the entire data. And there have been numerous benchmarks where the needle in the haystack problem we generally don't face with Gemini. Means even if the data is somewhere obscured in page number 5,000 something, it'll be able to fetch that. But RAG is also a viable option to answer that question.
Actually use RAG with function calling support. So Multimode Live API has a function calling support. So you can build your RAG system separately and then just connect it with the function calling. Yeah. That would work. But yeah, I mean, however that works for you. So what he said is also true. If you do not have like huge amount of PDFs and all, you can just stuff everything there. if you do have an enterprise system or some other like 10,000 notebooks, then have a separate system for RAG and then do the function calling, correct?
So one question, is this something that are intending to use in Google Glass, for example, which is constantly watching the environment around you and kind of
yeah, so that's why if you saw the funny name project Pastra, it was referring to Project Astra, which is what you're referring to. So
okay.
That is sort of 10 times ahead of what you are seeing of a lot of things latency, because they do have models which are slightly different than what we have. But yes, that's the direction we are going in, so that at some point you'll be able to build things like Astra or Google Glass.
Because I mean, because the amount of web sockets that need to be kept open would be crazy high. I mean, depending on the number of users.
Yeah.
So
eventually, that's what they are heading to.
Yeah.
But we'll see the consumer product very soon compared to the dev API. Dev will sort of lag a slight behind, but consumer will come
Good.
first.
Thanks.
All right.
I have a question. Can we take a
Yeah.
Yeah. So let's say for our audio use case, whatever we saw in the demo, whether it's a Vertex API or the raw Dev API, it's the client or the user who speaks first. What are the configuration we need to tweak if we want the agent to speak first for a particular use case? Let's say I am integrating to a call app which calls and says credit cards, where I am integrating the real-time API.
So you're saying the agent should speak first? Yes. Yeah, I think that can be handled programmatically, because when we do a setup, right, we're anyways establishing a connection. So you can set it up like once you do a setup, once the setup is run, you do a init, and then in the init you call that API with a text input. You don't have to expose the end user to it. Just call it as a text input with the, let's say, additional information like, oh, Mr. Doe, John Doe is there, bank account number this, credit card number this. You feed in all that information and then be like, now greet this user, and then start the conversation.
So there are parameters.
There are ways to do it. It's more of a programmatic thing. The parameters, I mean, parameters are definitely there, but it's more of a programmatic manipulation to take the first input as text and the subsequent as
that
you
would
can do
be
that.
kind of API agnostic.
Yeah. All right. I think we're done. All
Folks, if in case you have any questions, you can also ask them outside. Feel free to ask any questions. Also, we do have code craze running in Audi 1 at 1 p.m. So it's already started, so you may want to rush there. And thank you, Lavi and Gopala, for the lovely, insightful hands-on. Yes, round of applause for both of them.